Hey everyone, welcome back to the another episodes of Learn DSA with Sakshi. If you are someone who gets confused by pointers and linked lists, then don't worry. Today's episode is going to make everything super clear. We are going to explore how to create a static linked list using structures in C, and instead of dumping all the code at once, I have broke it down into three small parts which is easy to understand so we can focus on each concept more. So first program will be the basics of structure and pointer access. Then we create a linked list and it link multiple nodes, and then we access the data from the linked list. And the cool part is that we will also visualize each program with memory diagrams. So this diagram will help you see actually how memory looks behind the scenes and what values are stored where and how the pointers link everything together. So make sure you stay with me till the end because once you understand this, moving to dynamic linked list will be breeze. So let's jump in directly. So here are the three codes which we are covering today. First one is the understanding structure and pointer basics. Then after the first code, then we will create and connect the multiple nodes of the linked list. And after the execution of the two, we will accessing nodes using a pointer. So these three codes we are covering today. All right, enough talk. Let's dive right into program one and start building our linked list. So just make sure you open your Visual Code with me and write code with me. So here is our VS Code. Just make sure you open your folder and name file it to program1.c. So, all right, let's start with the first program. In this program, we are working with the basic structure that represents a node in a linked list. So I'll write code and explain to you. So let's start with header file. Also include the stdlib file. In the previous videos, we see how to create a structure node. So I'm just creating that one, structure node. Then two members are the data and the pointer. So integer data. Then this is the pointer next. So here is our the structure node. Then in the main program, first we create the object, then we create a pointer to that object, then we print it. So struct node obj, then struct node start ptr. Now just type that code with me. I'll explain you in details. Then object dot data is equal to 11 and ptr next is equal to null. Then printing j dot data. Make sure you type it correct. %d backslash 1 and then return 0. So here is our code. I hope you write the code with me. Now let's move towards the explanation of the code. So here we defined a struct node with two fields. First is the data, which is of the type integer, and then next, which is a pointer to another struct node. So here is the structure. Then in the main function, we create one object called obj of the struct node and a pointer ptr, which points to the object obj. Then we, for the assigning purpose, assigning data to object, we write obj.data. It assigns the value 11 to the data field. And then we write the ptr next equal to null. What does it mean? ptr next equal to null means that pointer which points to object has no next node. Means this is the end of the linked list here. So this tell when the ptr next equal to null, it means that it's the last node. So if you want to memorize it, let's draw a diagram of it. So as it having only one node, this is our obj1. So here is our object one. Then we have data, and next is 11 is null. So here is the memory diagram to visualize the code which we write. So here is the data, which is nothing but the 11, and next is null, which means it is the end of the linked list. And let's say it has an address of 100. So object 1 is at the address 100, which contain data 11 and next equal to null. So this is the diagram. Okay. When we print the value of object.data, one second. When we print the value of the object.data directly and through the pointer ptr, we get the same result, both showing the value 11. So, and just one important note is that don't confuse between the ptr next and ptr data. If we write the ptr data is equal to null, because data is an integer and null is used for pointer, not integer, so it gives error. So make sure you write here ptr next, not ptr data. So now just save your program. To run and compile the program, open your terminal. So go to in your folder where your code is, and then type gcc. I mentioned all these steps in the previous video. If you don't know, I'll repeat it here. So just make focus in it. gcc, then type your program name. So program1.c, and then minus o, so minus o, my exe. Just press enter and then type my exe.exe. So here is the output. We get value is 11 and value is 11. As I already told, we get for the object.data and pointer, we get the value 11 only, because we have only one node and the data of this node is 11 and the next node is null. So here is the first program for the basic understanding of structure and pointer access. Now let's move on to the next program. So just type program2.c, give it a name. And in this program, we will create multiple nodes and link them together to form a static linked list. Here is the upgrade version of the first program. So start typing with me. Struct node structure is same for this program also. So I just type it. Sorry, I here made a mistake. So in this program, we are making three different objects for the same structure. So struct node, and we give it name as object1, obj1, then struct node, obj2. You can write it in one line also, but I'm writing this in three different so that you will get a clear idea of it. Object3. Right. Now we giving data to this object. So obj, and how we do it? Obj dot data operator is equal to 11. Data is equal to, let's say, 51, and obj3 dot data is equal to, say, 101. And here is the interesting part. Just type it now and then I'll explain. Here is the complete program. Then up to this, it is same as the previous one. Here we just define three objects for the same node. Now we assign values to the data fields as obj1 dot data equals to 11, obj2 dot data equals to 51, and obj3 dot data equals to 101. It is nothing but the assigning values to the data field. Then we manually linking the nodes. So here is the interesting part of the code, how we link it to another node, right? So obj1 dot next is equal to and of obj2. It means that obj1 point to the obj2. So by using the dot next operator, we link these two, that obj1 points to the obj2. Similarly, obj2 dot next is equal to and of obj3. It means that obj2 points to the obj3, and obj3 dot next equal to null. It means that object3 has no next node. So this is the end of the linked list. So this is how we link by the next operator. For the better understanding, let's visualize it. So I'll draw a diagram for it. In our code, we connect the three nodes. So here I'm drawing the three nodes. Each one has the data and next pointer. One. Then next is the 51 and 101. This is what we write in our program. So let's say this is object 1, then obj2, obj3. So this is our object 1, object 2, and object 3. Now, if first object address is 100 and second, let's say it is 200, and address of the third node is 300. So what will be the value of obj1 dot next? So it is simply taking the address of the second node. So here it will contain 200, right? Similarly, it takes 300. And as this is the end of the linked list, it takes null. So this is the whole diagram for our second code, in which there are three objects, object 1, 2, and 3. And data of the object 1 are 11, then 51, then 101. And object 1, next, it holds the data of the next pointer. So it holds the address of next object, that is 200. And similarly, object 2 holds the address of the object 3, that is 300. You can also write it here. So it means that it is a pointer. It is for better visualization, nothing else. So yeah, this is the memory diagram for the second code. And this is how we create a simple linked list of the three nodes. This is how we manually connect multiple struct objects forming a linked list. This is just the static part, and we are not using the dynamic memory yet. Now, tell me, what is the output of this program? Right. As you can see, we are not include any print statement here. So this program It will not print anything. It will run perfectly. Don't worry. It don't give error and all, but it just won't give us the output what we want. If you want to try, just save your code and then go to your program number. So here's your two. Done. So see, here is nothing will print here, right? Because we don't mention the printing statement here. So we'll add the printing statement and how to access the data from the linked list. We'll see in the third part. So make a file and give it a name as program3.c. And just to save time, I copy this code and paste it here because everything is same. I just need to add something extra. But you don't just copy and paste, you write the whole code. So here struct node is same. Then object, yeah, we are giving three objects. Then these are the elements of the object. Then how to create it. Till this, it is same as the second code. Then now how to access it. How we are going to access the elements. So for this, we need to write struct node start first is equal to null and first is equal to end of obj1 and then print it %d \n comma first data. Similarly, first next data and then first next to next data. So just this modification we need to write in your code. So what is this? So we declare a pointer first that will point the first node of the list and we'll give it null value right now. We then assign the address of the object 1 to the first. So this is the line where we assigning the address of first object to the first pointer, right? Now using the first pointer, we can access and traverse the entire linked list. So if you can see here, first data. Now it will print the 11, right? Because it is the first arrow, then data. Then first next data means it will print the 51. And similarly, first next to next data means it will print the 101, right? So for the better understanding, I'll draw the diagram here. OBJ1, OBJ2, and this is OBJ3. Eleven, then 51, and 101. And this is the pointer first. If its address is 100, it's 200, and 300. Then first we'll take the address of the object one. So here it comes 100, right? And this is how it is linked to each other. And here comes the null. So this is the diagram for our third code, in which here is the first pointer, which takes the address of the object one, and then object one take the address of the object two, and finally object three. So this is how it we create a linked list of three nodes and accessing data. It's by the next pointer. So now let's move toward the code. I hope now you understand the whole code, how to access it elements and how to visualize the linked list. Now just save your program and to run and compile, open your terminal. So clear our command prompt and then just type this. Then here we see 11, 51, and 101. This is how we give input to our data 11, 51, and 101. So in this way, we got our linked list elements, and this is how we for just comment it. What will it print? It will print the 11, then 51, and this line will print the 101. Right? First data, first next to data, first next to next data. So this demonstrates how a head pointer first can be used to traverse a statically linked list. The first pointer acts as a head of the linked list, and we can use it to access and traverse each node using the dot next operator, right? So in this way, we complete our code and we create our first linked list manually. So what did we learn today? We saw the structure which contained the pointers and which allows us to build the linked list. Then we manually connected the multiple nodes to form a static linked list. Then we use the first pointer to access and traverse the list, right? Then, by visualizing the memory diagrams, we better understand how the data and addresses are connected. This concept formed the foundation for the more complex linked list operations and the dynamic memory allocation. But remember, don't just mug up the code. It's not about memorizing the syntax, it's all about the understanding and how everything works under the hood. Once you grasp this concept, the code will make much more sense, right? So that's all for today. In the next video, we will see more about how we can write a separate function for the traversal, then insertion, and how to use the malloc and create a dynamic linked list. So thank you for today. And if you found this video helpful, don't forget to like, comment, and share with your friends. And if you are new here, hit that subscribe button for more tutorials on the data structures. And thanks for watching, and I'll see you in the next one. Thank you.